Hello, Mr. Trong. My name is Jack Cobb, and today I'm here to discuss 2D arrays, what they are, and how to use them. Let's get started. So what are 2D arrays? 2D arrays are essentially arrays within arrays, and they are based on a row and column structure. The purpose is to clean up code in programs, and they're used for organization, and they are used to create grids. These grids can be seen in games such as Minesweeper, Connect 4, or Snakes and Ladders. And also they're used for organization purposes to clean up huge sets of lists. So it's fantastic for organizing. We'll start off with how to declare these 2D arrays. So declaring 2D arrays is very similar to declaring 1D arrays. There needs to be a specified type and the name of the array needs to be specified. Also, two squared brackets need to be put after the specified type, just as syntax, and also to show that it is a 2D array. There also needs to be proper syntax and 2D array structure when forming the actual array. And lastly, arrays can be autofilled, which is pretty cool. So, there are many different types of arrays, including strings, integers, double booleans, and more. And here's an example of a string array, string 2D array, int 2D array, double 2D array, boolean 2D array, and so on. And as you can see, each of these individual arrays only contain the variable type of what is specified previously. So the string only contains strings, the integer only contains integers, and so on and so forth. Also, what's cool to see up front is that these arrays are obviously designed in intent that there are individual arrays within these arrays. For example, this string array has two arrays within its own array. So we'll get more on how to inspect the individual elements later. Like I said, there's also methods and ways to autofill these arrays. This is the perfect example of an integer auto 2D array, which is 5 rows long and 5 columns long. And they're complete autofilled, so you don't have to specify what the actual values are in these cases. Now you must be thinking, well, what are these 2D arrays filled with? Because they can't be filled with empty space. And yes, that's correct. Autofill arrays, if it's an integer 2D array, are filled with zeros. String arrays, on the other hand, are filled with something called null. And the purpose of this is to basically refrain from the cause of any errors when all the elements haven't been filled out through the program. So now I'll demonstrate how to create these arrays, and I'll start off with creating a simple integer array, and right off the bat we'll show you how to create the overarching array. So there's just a simple array, and a one-dimensional array would also have elements such as this, or just has elements such as that. However, a 2D array would have arrays within arrays. And these would all be divided by individually divided by columns. And what we can have here is a bunch of integers in each of these. And as you can see, there's just a number of different integers in this array set. And right off the bat, you can see how this array has been constructed. There's obviously 1, 2, 3, 4 arrays within the one array. Now we'll show you how to create an autofill array. So we'll just use a string array for this example, set to B. And like we said before, we have to define it with a new array. So a new 2D array, all of the same type, so obviously a string. And then we have to set the column and the rows. And for example, we'll have 10 rows and 10 columns. And this would be a 100 element grid, 2D string grid. Full of the value null. Like I said before, it's auto-filled with the value null if it's a string 2D array. So this is how to declare 2D arrays. Now we'll be moving on to how to visually think of 2D arrays. And like largely said on the screen right now, as a grid is the best way to think of 2D arrays. And I'll explain. So, it is best to think of 2D array as a row by column grid. It's also helpful for when declaring 2D arrays, like we did previously, to declare them as a grid. So here are two examples of two differently constructed arrays, also with different values. But here's the first example, and it's a poorly constructed array. Because as we can see, it's on the same line, and it's messy. It's hard to read which rows and which columns, which elements access which locations. And it's unorganized. So why not create arrays that are organized and are easy to see in the formation of a grid? Here's a well-constructed 2D array that makes great use of this. It's obviously a grid, a 3x3 grid, and here we can individually see which rows and which columns each element's in. For example, the middle column and the middle section of the 2D array, it contains the value 7, is in the row 1 and in the column 1. So it's much easier to tell than, like, for example, if we were trying to figure out the row and the column of this, because you can't really tell. Anyway, we'll move on to a quick demonstration to keep things concise and simple. We'll do another integer array. And what I usually do is like to build the main array first, and we'll click enter. And what I tend to do is bring this value up like that, so it's nice and in line, and then bring this value up like this array individually here, and then just create my arrays like this, each individual array obviously, and separate each of them with commas obviously, because that's the syntax. And through here we can get started by just filling these arrays up with just nice simple numbers and integers. And as you can see, whilst I'm creating this array, it is very easy to understand and read where individual arrays are because it's all lined up nice and neatly. Obviously, arrays don't have to have the same amount of values in each array, as obviously this array right here has only 4 values, while this one has 5. But it's clear to see where, for example, this integer, number 5 right here is. It's in row 1 and it's in column 1. This, number 7, is in row 2 and in column 2. Now, the only downside is that when you create values that have more than 1 digit, for example, we could make 10,000, it does offset everything a little bit, because now it's hard to define which row and column this value is in. But still, nonetheless, it's much better than just creating a disorganized array such as this up here. So, that's how to think of 2D arrays visually. Now we'll discuss how to inspect specific elements. And it's very easy to pick out specific elements in 2D arrays. The format goes name of array, row number, column number, both in square brackets. It is also important to note that both row 1 and column 1 start at 0. So this basically allows for a nice simple counted loop setup when using counted loops, but also it's important to note that the last column number is not the total amount of columns in each array. So, it is through inspecting certain elements in arrays where the usefulness of these 2D arrays come into effect. And we'll go on to how to inspect certain arrays down here through a quick demonstration. So, here we have a nice organized array, like up before, full of values, and we can easily pick out which rows and columns each one's in, and this is great for the demonstration. So what would we want to do here? Well, to test that we are inspecting properly, we'd obviously like to create a print statement. And this, we would follow the formula where it's Array2D, row and column. So we'll just simply do the name of the array, which is inspected 2D array, and then we'll create the 2 sections to put in our row number and column number. And let's say we want to pick out this digit, this value, this integer right here, 42. And as we can see, it's in row 0, 1, 2. So it's in row 2. And it's in column 0, 1, 2, 3, 4. There we go. So now, when we run this, what we should get is 42 right here. And that's because we picked out exactly the location of that element. Let's say we wanted the one above it, 76. Well, obviously it's in the row above, so we would change that value to 1. And when we run it again, it would print out 76, like so. Now, there's something to watch out for when you are inspecting certain elements. And it's known as the element or range out of bounds error. And this is when you try and inspect an element that's actually not in the array. For example, if I were to plug in row 10, there is no 10 rows in this array. So when I were to run it, this program would return an error. index out of bounds exception error. And this is because I went too far out of line. So this is very important to know because this is the main reason why there are errors in programs that utilize 2D arrays. So we'll quickly delete that and we'll move on to how to print these 2D arrays. And yes, there is no function within Java that allows the print of a 2D array. So you have to do it manually. Printing 2D arrays is only done through counted loops and inspecting specific elements, like we already talked about. Now don't worry, this takes guts and also counted loops, but it's actually not that bad. For example, here is a string array, string 2D array, full of little characters that are all specified as strings. And obviously it's easy to tell that it's a well-organized string as it's got 4 columns and 5 rows. So what would we do? Well, first off, we need to recognize that we want to go through individually every single column and row. Obviously starting with this this letter first, then this letter, then this letter, then this letter. So we want to go through the columns before we go through one row. So obviously we would go and create a for loop, and we want to go through the rows first. So we create int row, which starts at 0, goes to the maximum amount of rows, which is there's 5 rows, so we go through that, and then row goes up by 1 every time. And then we create squiggly brackets, and we include another counted loop, this time involving the columns. So int column equals 0, column is less than 4 because there's 4 columns, and column goes up just in the rows by 1 every time. So now we actually have to print out individually each specific element. And this is done by inspecting the element. So we type the name of the array, which is printed 2D array, 2 square brackets, the row variable and the column variable, because these are the 2 variables that keep changing based on the counted loops, and this is what allows each individually element to be printed out. Now what's important to note is that every time we finish a row, we want to jump down one section to get to the next row. So what we would want is a nice simple print statement, print line statement, where we would create a new line every time a new row is printed out. And this would just help for the looks and the aesthetics of the printed out array. So once we print out, we can obviously see that the array has been printed out. A, B, C, D, X, Y, X, Y, cake, to A, 4, B, and whirl. Just like what's up here. So yes, it is rather challenging first to print out a whole 2D array, but in essence it's only 4 lines, and it's reasonably quick to do. What you can do is put this into a function, or a method, and you can keep calling upon that method every time you wanted to print out the 2D array. And this could, shorten down or concise your code, which is very useful. So that's about it for today. We've gone through how to print arrays, how to inspect arrays, how to construct arrays or visually think about them, and the different types of arrays when we declare them and autofill declare arrays. And we've also discussed the usefulness of arrays. Their organization's impeccable, and the reason why we use them in many games such as Minesweeper or Connect 4 is just simply for the grid. So ladies and gentlemen, and Mr. Strong, I am going to wrap this presentation up by just simply saying that 2D arrays are fun. Thank you very much, and I hope you enjoyed.